The next section deals with identical to section 3.5. Pretty much what we did. Add to that the complementary part. It says determine the general solution of the differential equation. Well, my equation has two components, y equal the complementary plus the particular. Let me get the complementary out of the way, which is the homogeneous. I'm gonna let y equal e to the rt. I'm looking at e to the rt times r to the fourth minus 1 equals 0. E to the rt cannot equal 0. R squared minus 1 into r squared plus 1 equals 0. So r equal plus or minus 1 and plus or minus I, which in the, okay, I keep on hitting the same key. So my fundamental set, e to the t, e to the negative t, cosine of t, and sine of t. So I got half of the problem. I already got that y equals c sub 1 e to the t plus c sub 2 e to the negative t plus c sub 3 the cosine of t plus c sub 4 the sine of t. Now what? Now comes the particular solution. That takes some time because they didn't give me initial conditions. I really don't need to find C1 and C2, not in this problem. Well, the reason I found this, if you recall, the reason I found this, to see if I need to modify the particular solution. The particular solution has two components. First component is a general linear equation. Y prime is A, Y double prime is 0, and all the rest are 0. If I apply that, I'm looking at 0 minus Y equal 3t. That means negative A equal 3, which means A is negative 3, and B equals 0. Alright, well, that means this part right here, the particular part, is actually minus 3t. So far, that's what we have. Alright, and now I'm gonna go for the second solution. Now, let me copy this here because I could tell already. I can tell already that I need some space because if I look for the second particular solution, it's going to be A the cosine of t plus B the sine of t, but it's right there. So what I have to do, I have to modify those. And how do you modify those? You tag a t. And I need 4 derivatives of this. Not a lot of fun to do, but it's doable. Y prime is A times the cosine of t minus at the sine of t plus b the sine of t plus bt the cosine of t. Got it. I need another derivative. Negative a the sine of t minus a sine of t minus at the cosine of t plus b the cosine of t plus if I could squeeze that a bit more, as much as I can get out of it, that would be awesome. So where were we? I got the derivative of that, I got the derivative of that. Okay. This, that. Okay, here. Derivative of b, that's going to be plus b the cosine of t minus bt the sine of t. Alright, I need 2 more derivatives to go to get the fourth. Triple prime is, actually, let me clean that up just a bit. So y double prime is actually negative 2a the sine of t. Does anything? Yeah. Minus at the cosine of t plus 2b the cosine of t minus bt the sine of t. the third derivative, let me switch colors on each, y triple prime will be negative 2a the cosine of t, product rule, minus a the cosine of t, plus at the sine of t, minus 2b the sine of t, minus b the sine of t, minus bt the cosine of t. Let me clean that up. That is negative 4a the cosine of t, plus at the sine of t, minus 3b the sine of t, minus bt the cosine of t. And if I go for another derivative, which is the final, fourth derivative, that would be 4a the sine of t, plus a the sine of t, plus at the cosine of t, minus 3b the cosine of t, minus b the cosine of t, plus bt the sine of t. And notice what I need. I just need this piece, which is what? 5a the sine of t, plus at the cosine of t, minus 4b the cosine of t, plus bt the sine of t, minus y, minus y. If I subtract at cosine of t minus bt sine of t, and all of that is going to give me a cosine. All of that is going to give me a cosine. Let me just go down a bit and write it all out. So let me see what we have. We're looking at the brown is right there. Does that combine in any way? Those two cancel out. Very good. And those two cancel out. I'm left with 5a the sine of t minus 4b the cosine of t, and that should equal the cosine of t, right there. So 5a must equal 0, and negative 4b must be a 1. That means a is 0, and b is negative 1/4. So my general solution is y equal the homogeneous the linear, and if I go for this 0 for a, so there's no cosine, there is 1/4 t the sine of t, and that would be my general solution. If they gave me initial conditions, I could find C1, C2, and so on and so forth. And there it is. Another problem, problem number 6. So, never a dull moment with those. They're really a lot of fun. There, plenty of space for us to do. Well, y is going to equal the complementary plus the particular. Let's get the complementary out of the way. We know that y equal e to the rt because that's a linear differential equation with constant coefficients. That's going to yield e to the rt times r to the 6 plus 1 equal to 0. And this is where complex numbers are going to come in very... Oh, r cubed. I went ahead of myself. Forgive me. We're not there yet. So e to the rt cannot equal 0. It must be r cubed into r cubed plus 1 must equal 0. R equals 0 multiplicity of 3. What does that mean? E to the 0, which is 1, e to the 0 times t and t squared, and r plus 1 times r squared minus r plus 1 equal to 0. So I have so far, okay, r sub 0 equal 3, and I have r equal negative 1, that gives e to the negative t, and this is going to be r squared minus r plus half of the middle number squared is 1/4. That would mean that I'm looking at r minus 1/2 squared equaling negative 3/4. So r equal 1/2 plus or minus radical 3 over square root of 4 is 2i. So that's going to yield a nice solution. That's going to yield e to the t over 2 cosine of radical 3 over 2t and e to the t over 2 sine of radical 3 over 2t. That will form the fundamental set. Since they didn't give me initial conditions, I know how that works. Y equals c sub 1 plus c sub 2t plus c sub 3t squared plus c sub 4 e to the negative t plus c sub 5 e to the t over 2 cosine of radical 3 over 2t plus c sub 6 e to the t over 2 sine of radical 3 over 2t. That's half. The other half, the particular solution, is going to be the general, and I need 6 derivatives. Y prime is a, y double prime is 0, and the rest are 0. If I plug those in, actually, I messed up big time. That's a general solution, but I need to modify. Do you see how many times I need to modify this? Do you see there's a t squared there? Even if I multiply this by t and a t and a t and a t squared, I'll get the particular to be at cubed plus bt squared. But bt squared is there. I modify again. I'll keep on modifying until none of these terms are in my fundamental set. Why is that? Because I want them to be linearly independent. Now I need 6 derivatives. 4at cubed plus 3bt squared. Y double prime will get 12at squared plus 6bt. Triple prime 24at plus 6b, and the fourth derivative will give me 24a plus 0, and everything after that is going to give me a 0. So out of those, this is what I'm getting when I plug them in. The sixth derivative is 0, plus the third derivative. I have 24at plus 6b, and that should equal a t. That indicate that 24a equal a 1 and 6b must equal 0. That means a is 1 over 24 and b equals 0. So if I come to my actual solution and I plug in what I have, pretty much that does it. Plus a is 1 over 24 t to the fourth plus 0, no need to list that. That would be my general solution for this problem. Right? Let me see if I could do, maybe I should do the whole thing one shot, or should I wait? I have 3 to go. Okay, you know what? I'm going to do that in another video because that's going to take some time.